And then other people can look at it too. It can decide if they agree with you. So you're saying you line things up. So I'm going to write the top one, and then you can tell me where you want things after that. Okay, so go ahead.
And then the bottom, it would be 2d2 plus, no, minus d.
So you put the 2d squared here and then put the d there, right? Okay, and we're doing this as a subtraction problem.
Yeah. So I got 2d over 2, or 2d2.
Okay.
Plus d. No, plus 2d. Plus 6.
Plus 6. Okay. So I saw some other people's answers out there that were different from this, though. Hey, Jackson, could you explain how you thought about this, or Gregory? Because you guys had a different answer. What was your answer? Jackson, let's start with you.
Okay, well, my answer was 2d squared plus 4d plus 6.
Okay, and how did you get to a 4 instead of a 2?
Because it said subtracting, right? So it'd be like subtracting negative d. In other words, adding a d. So then that's how I got 40.
Okay, really good catch. Gregory, was that what you were thinking too? Because I noticed your answer looked pretty similar to Jackson's.
Yeah, but I kept it a negative.
So you kept a plus a negative 4d.
Yeah.
Okay, and those are the same. Granted, my 4 is pretty sloppy. Okay, so what both of them noticed is, and this is the really key point here. So I'm glad we have different answers, different ideas how to do this. The key point to think about, guys, is really you are subtracting this whole thing. And so putting parentheses around this can be very helpful to you, because if you were to write it sideways, right, you would have seen it would be this minus in parenthesis 2d squared minus d. And in this point, you would remember, oh, wait, there's a 1 here. There's that implied coefficient of 1, and it's negative. And I would need to distribute that negative 1 to all my pieces, right? So when you see we stack it this way, I'm just going to draw a line here so we realize where the problem really stops, that this is kind of our other horizontal notion. When you stack it and you put this subtraction sign out front, you have to distribute the subtraction sign, or you could just think about it as subtracting a positive, and now I'm subtracting a negative, right? And as Gregory and Jackson said, if you're subtracting a negative, then you end up with a bigger positive number. Do folks have thoughts on that? Questions about how that would work or why it would be that way? Yeah, so you could go with either of these styles of answers. This is probably the preferred one. Just, this doubling up gets messy, but it's still completely right. So Gregory, you got the right answer. Just be careful about your signs. Okay, we're going to be doing a bunch more like this today, but this is the general idea. Now, some of you, and we saw this in the last unit, like a lot of people didn't really want to subtract exponents. You wanted to turn everything positive and then treat it like adding your exponents, right? So if we had a division problem or we had a problem involving negative exponents, you wanted to turn all of the negative exponents positive and then add everything when it was positive, right? You just didn't like dealing with the negative. And you can absolutely do that here. Now, you could take every subtraction problem if you wanted to, and you could say, well, it's 4d squared plus 3d plus 6 minus 2d squared minus d. Well, I don't want to do a subtraction problem. I want to turn everything positive from the beginning. So this becomes positive, so that becomes negative, so that becomes positive. And now it's just an addition problem, right? And somebody actually said that in the chat earlier. I can't remember who it was. Who was it that said that? Yeah, Sanvi. Sanvi said it's the same thing, but subtraction, right? So addition and subtraction are two sides of the same coin. You can turn one into the other if you just flip it over. Right? And then you would know this was 2d squared plus 4d plus 6. So if this is an easier way to think about it, just make sure you're changing all of the signs. Right? You can't miss one or you'll come out wrong. So whichever one of these two ways you would rather think about it, they're the same thing. Okay, so I'm going to open up the next slide and you'll see the explanation on that. And I'd like you guys, there's a couple of check boxes there. Pick the one that that feels like you. So we're still waiting for some folks who are hanging out on slide 4. If you're on slide 4, then you can't be giving me your opinion on slide 5. And there's still somebody way back on slide 3 too. So everyone should be on slide 5 right now. If there's something that you don't understand, then this is a good chance to ask me to explain it again. And I do have a couple requests to explain again. So let me give you another problem that's slightly like this, that's related. And let's talk about why it works this way again. Okay, so let's try a different one and let's go sideways again. If I told you 6x squared, and I wanted to know the difference between 6x squared and a negative 5x squared, and I told you I wanted you to subtract that. Here it's only two terms, right? There's a monomial and another monomial, and it's only two terms. And here you can easily see, wait, those are right next to each other. And if I had written it sideways, you would see it was 6x squared minus a negative 5x squared, and you would still see those negative signs right next to each other. And that would be a good clue that, hey, if I am subtracting a negative, it's the same as adding a positive. And so the same thing happens here. They're right next to each other. So this is the same as 6x squared plus 5x squared. And either way, and this way too, and this way too, all of these ways, you're going to come out to 11x squared. The thing that gets a little more challenging is, now if I say that it's 6x squared minus 3 minus 5x squared, sorry, I'm going off the edge of the paper there, minus 2, right? Now there's a lot more distance between this negative sign and this negative sign. And now when I stack it, and I'm still subtracting, now it's harder to remember that this negative sign and this negative sign are still connected in the way that they were here. But it's really the same thing. Anything inside, if you're subtracting a negative, and this 2, you're now subtracting a negative 2, is the same as adding. So here now, because I took the negative sign off of the 5x, now when I subtract, I only get x squared, because this one isn't negative in this example, but this one is negative. So I am subtracting a negative 2 from a negative 3. And if we wrote that out, negative 3 minus a negative 2, well, this becomes positive and that becomes positive. Negative 3 plus 2 is negative 1. And so this would be a negative 1. Okay. So that is the main purpose of our lesson today, is subtracting polynomials. And like I said, if you would rather have turned this into an addition problem first and worked it as an addition problem, you could do that, right? You would change, so I'd say, well, I'm gonna make that positive, so that becomes negative and that becomes positive, and it would still come out the same way. If you want to flip all the signs, every last sign, at least in the part that's being subtracted, you can turn it into addition problem, or you can keep on thinking about it as subtraction. Okay, we're going to go on though to the next slide. So, and I'm going to actually open up a bunch of them at once, but just kind of hang with me. So actually, let me do this. I'm going to switch what I'm sharing my screen, because then we can go through this